I'm so lonely. Begin. Given two integer arrays, nums 1 and nums 2, return an array of their intersection. What's an intersection? 2, 2. 2, 2. Okay. It's just the array that appears in both arrays. 4, 9, 5. 9, 4, 9, 8, 4. It's just the array that appears in both arrays. An array that appears in both arrays. So you could just look at the smaller array and say, does one item from the smaller array fit in the larger array? Yes. Does two items from the smaller array fit in the larger array? Yes. Does three items from the smaller array fit in the larger array? And say yes. At least that's what I'm thinking. I don't know why this is also accepted, but maybe we'll find out soon. What if the given array is already sorted? Oh. I don't think I typed this. I feel like I looked at this question a little bit before, but I didn't go through with it because I just decided to do the remove duplicates question. Well, that's fine. I said I was going to do this one, so let's do it. And I never actually solved the problem, I just looked at it. No, let's not look at the follow-ups. I feel like these are red herrings. Oh, what if the given array is already sorted? Does that mean I have to sort the array? No, that's a trick. Don't believe it. What should I do? Oh, let's think about that naive implementation I just described. Hold on, thought. Let's get some water. Gotta stay hydrated, especially when you're very slightly sick. Okay, but the coughing is causing a bit of a headache though. It's actually hurting me. I have to try and hold back. In the chaos. Anywho. Yeah, let's do that. Let's just take one item of nums 1, check if it's in nums 2, then slowly progress it. Yeah. I'll put the naive implementation and then optimize that with a hash map or something. That's what I did before with remove duplicates. I looked at like both lists, and I looked at one list, and then for each item of that list I iterated through the other list. But instead you could use a hash map to cut the iterations a lot. Alright, without further ado, let's get started. So I want an index of nums 1, so I could say nums1I equals 0. So I'm looking at the first item of nums 1 currently, and I'm seeing for n in nums 2. Ooh, wait. We're gonna have to eventually split, right? So for, hold on. We could actually do something else here. Nums 1, we could do a window, and then the window increases. So like, let's say we're looking to see if a 4 is in nums 2, right? Is a 4 in nums 2? I just realized I put my finger on the screen, but you guys can't really see what I'm pointing at. Put 4, oh, that's what the cursor is for. The cursor is just a finger on the screen. I'm so cool. 4 is in the list, and if it is, then we increase the window. So then the beginning of the window is now 4, and the end of the window is now 9. Before, the end of the window was just 4. So we could say nums1 window start equals 0, or nums1 window end equals 0. Then when we find a 9 after the 4, then we reset, or we go back to the beginning of nums 2 and we look again. But this time the window is all the way up to 5. Y'all see what I'm going for here? Every time we find our window inside of nums 2, we expand the window. So, how are we going to implement this? Well, we're going to have to iterate through nums 2. I don't know how exactly I'm going to do the iteration. I don't know when I stop and when I end. So for now, I'm just going to say for I in range length of nums2. I'll keep this as a placeholder for now, because what I really want to focus on is what I've already determined, which is the condition of whether the window will expand or not, or whether we keep looking through 2. Because that's what we do at every iteration, right? We make a decision. Do we expand the window and reset to the beginning of nums2, or do we expand the window? So if, by the way, we also have to output our list somehow. If, we just have to do a split operation now. If nums2 from nums1 window start, nums1 window end. But now I'm starting to realize we need an index to see how far are we in nums2. So I could say I plus nums window start, I plus nums window end is equal to, and then I just do this. I need to look, or I need to get a list that's the equivalent of the window. So I could do window equals nums1, nums1 window start. Oh, I just realized nums1 isn't necessarily going to be smaller than nums2. So I should actually identify which one of these lists is the smaller and which one's the bigger one. For now, I'm going to assume that nums1 is smaller than nums2, and then I'll replace it later. So let me make a note for myself here. I'm a responsible programmer. Change var name so that the window captures the smaller list. There we go. So nums1 window start to nums1 window end. Or better yet, maybe we could do this. If length nums1, yeah, I've decided to do it now. Length of nums1, I feel like it's going to get a little distracting because the more I write code here, the more lost I might get in the future. Greater than nums2, then small equals nums1. Wait, no, small equals nums2, because nums1 is bigger. Big equals nums1, else small equals nums1, big equals nums2. Then I just say small window start, small window end. Then for I in range of the length of big window is, can I find and replace everything? I guess not. Or at least if there is, I don't know how to do it in LeetCode. Small, oh boy, time to replace everything. I was gonna do this eventually, so it's good that I did it now before the code got too crazy. Small window start, small window end, if big at I plus small window start plus small window end is equal to the window then we want to expand the window. So let's show that here. Small window end plus equals 1. There we go. And otherwise, then we just want to move I up. So that's going to happen naturally with the for loop, so let's just pass. Oh, but wait. We need to make sure that that I plus the window end does not index outside of the list. That would be bad, very bad. So let's go ahead and add a check for that. And if it's if that happens, then we break, right? Oh wait, 9.4 is also accepted. Just okay. So I guess the order doesn't matter. Anyway. We have to check if our thing is outside the window. Ooh, and also we have another check, right? If small window end is greater than length of small minus 1, because length of small minus 1 is our max index, of course. Or we could actually do this: greater than or equal to the length, then return small, and then we have to say the intersection of both lists. Ooh, okay. I don't know how to return the intersection of both lists yet, so let's just say return intersection. Because the thing is, what if it's 0 items? What if there's no intersection? Yeah, it looks like there's no guarantee that there will be an intersection. I could do a test case later to see whether an intersection could be empty, but let's do that later. Return intersection. There's a lot of things to do. I gotta make sure to keep everything managed in my mind. The next thing I wanted to do after this was I'll do that. Return ... That's a placeholder. Now we have to check if the window is bigger than big. So if small window end plus I, because that's the index that we're using for the big window, is greater than or equal to length big window, or length of big, indexing outside of big, then we're done looking for the intersection, right? That means intersection not found. Return intersection. There we go. Indexing outside of big means that the intersection was not found, then we return the intersection. So let's do the same thing here. Ooh, actually we could combine these two statements. So small window end is this, or I plus small window end is greater than or equal to length of big. Indexing outside of big means intersection not found. Return the intersection. Return. Now we go here. Window equals small window start, small window end. If big, I'm just making sure that all the code runs as expected and it does generally the right thing before working on the intersection. So here we expand the window, right? We correctly expand the window, but we don't go back to the beginning of the list, now do we? No, we don't. It's a good thing I checked here. So now let's go ahead and take I. Ooh, but wait a minute. A for loop will just iterate through all of the values in the range, but will it be able to adapt when I changes? Just to prevent that from happening, because I'm not sure of the result here, I'm just gonna go ahead and change it to a while loop because I'm certain that's gonna work. So while, and then we have to declare int I outside here. Oh, we don't need to put int. Python is duck typing. I equals 0, while I is less than length of, yeah, it's the length of big. Or actually, no, it should not be. I presume that we can break out of the while loop, right? But just to be safe, I'm gonna make it so that the while loop can also break on its own if it needs to. So while I is less than length of big, doesn't hurt to play it safe. Less than, yeah, length of big. Minus the small window end. I was trying to figure out there when I was thinking for a second. I was trying to figure out what I's max value could be. And I say, yeah, it's big minus the small window end, because the small window end is also the same as the length of the window. So there we have it. Now we're always indexing in the small window end. I could also include the same condition here, which would also cause return. Okay, now that I think about it, this while condition kind of negates the purpose of this if statement because, oh, but no it doesn't, because this while loop checks after every, or this condition checks after every iteration, but this checks at the beginning. But is there a case where the small window end increases by 1 and then this condition runs and then we get an error? Honestly, I believe not. So yeah, we can go ahead and move this code safely. But I will keep this note just so I understand this code for later. There we go. While small window end is greater than or equal to the length of small. Or, wait, no, and, because you have to make sure that it keeps running. Small window end, while small window end is less than, we have to reverse the condition as well. While small window end is less than the length of small, and I is less than the length of big minus small window end. Or actually, we can make this more clear by saying I plus small window end. There we go. It is good to have clear code for people to understand when they work on it later. Nice. Now we don't have to have this redundant code. There we go, nice and simple. Window equals small window end. Expand the window, of course. It's a good thing I didn't lose track of this, but I was able to remember that after we expand the window, we actually have to return to the top of the list. Or return the while loop. Or I mean, we have to return the index to the beginning of the big. So all we have to do is set I equal to 0 again. And of course, at the end of every iteration, now that we don't have a for loop, we have to actually manually increase I by 1. And there we go. Expands the window and bring I back to the beginning of big. There we go. Now, all we have left to do is to actually get the intersection. Alright, now, in order to know what to return, we have to know what happens if nothing is found, because there could be a case where there is no intersection between the arrays. Or at least, the problem doesn't specify whether or not the arrays will or won't intersect, or whether they're guaranteed to intersect or not, so I'm just going to guess that there's a possibility that they don't intersect. So what do we do if they don't intersect? Well, the small window starts 0, ends 0. Okay, right now we're assuming that the window is 1 item large, but then does that mean if we complete the while loop and we just use the window indices to index into small and then return the split of small based on the indices, does that mean we'll return 1 item and not 0? That is what that means, doesn't it? So we have to find a way to return 1 item instead of 2. Or we have to find a way to return 0 items instead of 1. Perhaps we could try something. If small window start at 0 and small window end at 0, if that is not found at all in nums2, or if it's not found at all in big, we just return an empty list. How do we do that? How about this? We can do a little flag here. I think that's the simplest way of doing it. We could say intersection found equals false. False. Now, we could say if we found the window inside of big, then we found an intersection. There we go. And then if we come to the end of the while loop, so we search through big after expanding the window and found nothing. Or we searched through big without ever increasing the size of the window. That means that intersection found is false. And then if not intersection found, return an empty list. Else, of course, we want to return small, because that's our limiting factor here. Followed by small window start, and ending at small window end. Except wait a minute, when we split on small window end, this is not the last index, but the last, it's the last index non-inclusive. So for example, in Python, if we split from 0:1, if we had start at 0 and end at 1, we would actually only get one item. So by making it 0, we're actually checking if any part of big is an empty list, which will never happen. So we actually need to initialize this to 1 in order to have a proper thing. In order to have a proper window. Now, what are the constraints? I'm checking to see if any of these could be 1, length of 1. So nums1 has to be greater than or equal to 1. Okay, so there's no 0 item nums1 length. That's helpful to know. Nums2 length is less than or equal to 1,000. Does that mean it could have 0 items? Is that a possibility? Or am I to assume that nums2.length is also greater than or equal to 1? I don't think that's like that. I'm not sure. It feels like a weird thing to have, you know? I'm just going to assume that nums2.length is also greater than or equal to 1. Because otherwise this seems like a weird thing to say. Like, you're telling me the lower limit of nums1 length but not the upper limit, and then you're not telling me the lower limit of nums2. So that's why I believe that they share the same bounds, nums1 and nums2. So if we didn't find an intersection, return nothing. Otherwise we return small window start, small window end. And yeah. I believe this is all the code I need, so let's go ahead and run it. My answer was actually no. Oh, whoops, I forgot to say return here. Silly me. So this means something was found. My answer is 2, 2, expected answer 2, 2. Let's see if that was a lucky fluke or if that's actually the code running as expected. Let's go ahead and put 495, 94, 94. Honestly, if I really think about this, this is not, I think, the most efficient way of programming. Oh, interesting. Did I put in the inputs correctly? I think I did. Just to verify, if I put in 1, 2, 2, 1 on one line, and then 2, 2 on another line, it'll output the correct thing, right? Run code. Yeah, there we go. Okay. So I think I did put in the input correctly, but I'm outputting the wrong thing. I think I see the problem here. My code is searching through the whole array, but if small window or end, if the final item of the window, which in this case is 5, if it is found, or if it's not found, we return it anyway because we're not decreasing it after the search. So after the search completely ends, we should okay, what do we do when the search is completely ended? We have to decrease it by 1, right? But we only do that if there wasn't intersection found. So small window end, and this equals 1. Now this does feel weird because the output was correct last time for 1, 2, 2, 1, but this should be correct here. Yeah. Okay. I'm expecting this to not work now. But I could be wrong, so that's why I want to test it anyway. Yeah, now it is wrong. Interesting, interesting. So now what I want to do is mentally execute the code and see why there's a difference between the two test cases. All right. Oh, and yeah, to go back to what I was saying earlier, this is not how I typically code because I'm putting in a lot of features. But the thing is, I feel confident enough to mentally execute the code as I'm programming it to be able to write code and then just continue writing code. Because normally what you'd want to do is test-based development, right? And develop incrementally. So what you'd want to do is add one feature, then test that feature, then add another feature, and then test that feature. But here, I can mentally execute the tests on my own and realize which parts I'm missing piece by piece. The only drawback is that if there's a bug, then you have to mentally execute a long section of code, but if you believe you have a final implementation and then you have to, and then somehow it doesn't work, then you're gonna have to go through all the test cases all over again anyway, so. That's why I don't blame myself for going the way I did. I don't regret choosing this way of thinking where I could just mentally execute code while I'm programming it, but anyway, that's besides the point. I just wanted to talk about what my train of thought here was. Wow, my jaw is weird looking at this angle. Here we go, much better. Also gotta sit up straight. My lower back was curved there. That's not healthy. Let's begin the mental execution. But, okay, let's begin the verbal execution because I'm actually gonna be talking. Nums 1 is 1, 2, 2, 1. Nums 2 is 2, 2. Nums 1 is longer than nums 2. Indeed. So nums 1 is big and nums 2 is small. Excellent. And we set our small window start to 0 and small window end to 1. Our I is 0. Intersection found is false. While small window end is less than the length of small, which it is. Small window end is, wait, no. Yes, it is. The length of small is 2, and 1 is less than 2, so this runs. And I, which is 0, plus small window end, so that's 1 in total, is less than the length of big. Yes, it absolutely is. Then, okay, now we know we can continue on with the while loop iteration. Our window is equal to small. All right. Small window start, small window end. All right. So what are we looking at here? We're looking at an index where we have a 0 split with the 1 up here. So we are looking at just the first item of the array. Because remember, this last index tells you what is the non-inclusive upper bound of the window. So we are not including the item at index 1. So this is just basically the same as small bracket 0. Okay, so now if big I plus small window start, okay. So now I is 0, remember? So we are looking at big item 0, actually. And if it's equal to window, which it's not, 1 is not equal to 2, we just pass, and then I is increased by 1. Now small window end still less than the length of small, yes. Small window end is now 2, ooh, hold up, actually. Wait a minute. Small window end is now 2. Okay. Now that small window end is 2, we actually break out of the entire while loop. And then we did find an intersection, which is, no, actually wait, we didn't find an intersection. So we just returned small at small window start to small window end. So that's 0 to 2. Wait, what? No, I definitely missed something here. No, wait, okay, we did find an intersection. I forgot. The pass that I did, I thought that was the first iteration, but it was the second. That's my bad. So we actually did find an intersection. Our small window end is now 2. Then we exited the while loop entirely. Now we found an intersection, so we don't return this empty list. We return small from 0 to 2. Okay. Oh, but the thing is, isn't it also possible that the window could start at an index that's not 0? What if our window starts at or what if the match was 9, 5, for example? Oh, that's tragic, isn't it? Okay. It's a good thing I saw that flaw in my implementation. Oof. Okay, with a problem this complicated, you see, I was able to solve rotate array and remove duplicates at this point in time, so I probably won't be able to finish this in time. I do not have infinite time on my hands, unfortunately. I do have to study for my final on Thursday and go to sleep. But I can at the very least come to a naive solution, can't I? So now let's figure out why 4, 9, 5 is not working. Because I'm outputting 4, 9, 5. Boop. And boop. Run the code. Yeah, I'm including one more. And I'm guessing... No, I know for a fact that it's because small window end is too big. But why? Why is that? Okay, well, we know that the first 2 iterations run, so I'm just going to go ahead and skip those 2. Why do I know the first 2 iterations run? Because this test case is the same as the other test case. Yeah, this example 2 is the same as example 1, only the only difference is that nums1 has 3 items this time. So how does this work then? Well, small window end. Okay, for now, after 2 iterations, what is small window end? Because we expand the window twice. Yeah. We expand the window twice because we have to do a final third search that then finds nothing. So small window end is now 3. That's why we outputted 4, 9, 5 and not 4, 9. So small window end is 3 and it's less than the length of small. Well, that's not true anymore, so we return. So let's go back an iteration, all right? So we found the iteration where we got an error, so now we can travel back in time to see what caused it. So now we are at the previous iteration entirely. So small window end is still 2, which is less than the length of small, which is 3. I is 0 because we set I to 0 with this line on the previous iteration to this one. So 0 plus 2 is less than the length of big because the length of big is 5. Now we have our window. Window is now 4, 9. And if big at 0 plus 0 to 2 is equal to the window, which it's not. 9, 4 is not equal to 4, 9. Yeah, when you do list equality, it checks the order of the items in Python. intersection found as true, small window n is plus equal to 1, I is 0. Then we, oh, wait a minute. Why are we increasing I here if, oh, okay. So I is actually starting at 1, isn't it? So what I really intended to do here is just continue. All right. You see, it's adding 1. Which may have caused an early stop, perhaps? Oh well. In any case, this is the code I intended to write, so let's see if that works. No, it did not. So unfortunate. Okay. Okay, 36 minutes have passed in the recording. I don't know how this took so long, but in a real interview, I really don't know if me and the interviewer would spend this much time on a single problem, especially with no outside interaction. So I might just call it at like 40 minutes. But anywho, looks like continuing didn't work, so I'm gonna have to try something else. Window. Well, actually, perhaps there's a faster way to do some testing here. I could simply print what the window is. So let's go ahead and have some log statements here. Print I. All right, this is another lesson. When you don't know what's going on, do some print statements. What did I learn from the previous problem, which was rotate array? You have to change the items. Okay, when you pass in a parameter to a function, and then you reassign the name of the parameter to a different variable. Like if I said nums1 equals new nums, all I'm changing is a local variable named nums1. All I'm doing is changing a local variable that has the same name as my parameter. But if I were to return my parameter, I would actually be returning a reference to the original parameter and not the local variable copy that's made in the middle, or in the function body. So now I know, if I actually want to change the reference itself, I have to use index operation, assuming it's a list. I don't know if the same logic works with strings. I'm gonna have to find out next time. So, print it f string I. There we go. Now we can see what I is. We could also see what our window is. So we'll have our window, small window, start, small window, end. There we go. Now if I run the code, it should show me some stats. Oh, what in the world? That is how you do an f string in Python, is it not? Invalid syntax. Am I using the wrong symbol? That's not correct either. Oh well, I could just say I, then as a separate argument I could say I. I could say window, small window starts, there we go, small window end. Oh shoot, I added an extra quotation mark there. Let's not do that. What? Oh, I forgot my comma. There we go. Okay. Thank God. All right, I is 0. We have a window from 0 to 1. So we didn't find 9, or 9 is not equal to 4. Then we look at index 1. Oh, would you look at that? 4 and 4 are equal. So now it goes back to the beginning. I is now 0, and our window is 0 and 2. Now we're looking at 4 and 9. And we find it. Wait, do we? No, we don't. Yeah, so now we look at I is 1 from in Windows 0 to 2. Then we find it. But then, after that, we actually just end everything. We increase the small window n plus 1. Then our small window end is too big. Small window end is less than the length of small. 0, 1, 2. Oh, I think I see what's happening here. I think I'm ending it too early. Because, really, small window end should be able to actually reach length 1. Or the length of nums 1, or length of small. So if this is 3, for example, small window end is 3. That is possible. So we have to say less than or equal to length of small. Because when your end is 3, the last index you could get from nums 1 is 2. Then I plus small window end has to be less than or equal to the length of big as well. Yes, yes, yes. Okay. Now let's see if that helps at all. No, it does not. Unfortunate. It is a correction in logic, however. Just out of curiosity, does it actually work for 1221? Oh wow. Okay, that still works. Alright, unfortunately I'm out of time for this problem. I'm gonna have to call it a day here. I hope you were able to fall asleep. And hopefully the next video that plays after this one is not super loud, so to wake you up from your nap or from your bedtime. Before I go though and call it a night myself, I really want to know the best way to solve this problem. So let's go ahead and screenshot this and send it off to our tutor. Alright, let's go ahead and send it to ChatGPT. So ChatGPT, being ChatGPT, has decided to use the optimal solution, a hash map or counter. So, here it is. What? Why? Oh my goodness, yo, this is so show. Oh, it uses a Python collection. Oh. Is that cheating? Is that cheating to do that? Are you allowed to do that? Like if I just put this into, the code, I guess I was sort of implementing a collection myself if that's the solution, right? So I'm gonna go ahead and paste this in, define intersect nums1, nums2. Oh, of course you need self, however. From collections, import counter. If this gets flagged by LeetCode, then I'm gonna go ahead and ask ChatGPT to regenerate. Hopefully the indentations are correct as well. I know sometimes code engines, they start yelling about, oh, I didn't need this function header. They start yelling about you not using the right tabs. Oh, you didn't use the Vim tab. So, okay. So that's correct. And I didn't get flagged at all for using a collections library. Let's go ahead and paste this in. Wow, my energy level has increased quite a bit after seeing this. Oh, okay. Let's see if I could interpret the solution myself instead of using ChatGPT. Count equals counter nums1. For num in nums2, if counts num is greater than 0, result of append num, and then counts num minus equals 1, return result. Oh, okay, so we're looking at every single number in nums2. And if counts bracket num is greater than 0. Okay, I thought I could figure this out easily, but I think there's some logic in the counter that I'm not really clear on. Aha, this is what counter returns. It's a dictionary, or a hash map. Less syllables, more efficient. It gives 1, 2, and 2, 2. So there's 2 1s and 2 2s. Then we loop through nums2. First 2 in counter, append decrement counter, second 2 sling counter, append decrement counter. Okay. 2 is in counter, because 2 is a key inside of the hash map. Append the 2 to the results, which is a separate empty array. Then we decrement counter, so now it's 1 to 2, 2 to 1. Then we see our second 2 in nums2. 2 is still inside of our hash map. We append the second 2 to our separate array that I'm imagining down here in this area. Wow, my cursor really swelled up there. And then we decrement the counter. And now we're done looping through nums2, so we found the intersection. So this... Okay, if I ever get a question like this in the future, I'm definitely using Python. Because... Okay, yeah, I do not know if I would be able to do this in C++. Let's see, it's not the fastest of all Python implementations. I'm guessing the solution is still more powerful. Anyway. I really felt the palpable phlegm in my throat right there. Oh, that was nasty. Apologize for the vivid description. So let's go through a mental execution just as a final exercise to really hammer home the solution here. Let's think about nums2 here. So if we get the counts of counter nums1, we get there's 1 4, 1 9, and 1 5. So 4 1, 9 1, 5 1. There we go. That's our counts. Then for every num in nums2, if counts num is greater than 0, okay. For every number in nums2, so now we're looking at 9, is 9 inside of nums1? If so, append it to the result. So now the result contains 9. And then decrease this, so now it's 0. Now we look at 4. Is 4 in nums2? Yes, so we append 4 to the result. Then we decrease this by 0, or by 1, so now this is 0. So now we have 4 colon 0, 9 colon 0, 5 colon 1. Then we never find anything in counts that's greater than 0, so we just end up exiting the for loop and returning the result. Okay, so you know what that tells me? That tells me that I didn't need the window, because I thought these numbers had to be next to each other. I guess that's what this was telling me, but I thought, oh, it's either you have 4 9 in this order, or you have 9 4 in the reverse order. I didn't realize that it truly meant that the order does not matter at all. Okay, that's unfortunate that I did not realize that. I could have come up with a much simpler implementation if I knew the problem, but I do think this problem was less well-defined than rotate array and remove duplicates. Because all things considered, this being able to just count which items appear in both arrays is not that hard of a task. I mean, I'm not going to do it, but I can imagine that it's not too difficult. So let me just clarify one more thing with ChatGPT. When they say intersection. Oh wait, I can just cut out the typing. Okay, I accidentally hit enter too early, but I think ChatGPT figured out what I was trying to say before I messed up my example. So intersection is actually a multi-set of values that appear in both nums1 and nums2, regardless of their positions or order. It does not mean a contiguous subarray. It does not mean a contiguous sequence. So the items don't have to be next to each other. They just have to be contained in both. Ah, okay. So actually, the flaw was in my understanding of intersection, because now I'm actually remembering. I thought intersection meant like two arrays having a sequence in both arrays, but no. It's just a subset. Like if you have an intersection of two sets, it's just the set that appears in both of the sets, right? It's the same thing with arrays. It's just an array that appears in both arrays regardless of order. Longest common subarray. All right, that makes so much more sense. Anywho, much longer recording this time. I did not mean for it to go this long. I'm sorry. But hey, if it took a long time to go to sleep, I guess this was the video for you. Kevin McLeod is going to come up with the jazz real soon. I want to have a recording where there's no Kevin McLeod jazz and a video where there is Kevin McLeod jazz. Just so there's some variety, you know? Because if it was all one thing, then we'd never know what happens if we had the other thing, you know? I also hope my voice is soothing enough. I'm kind of forced to speak in this low tone of voice that I don't usually use because my whole family is asleep right now, and I want to make sure they keep having sweet dreams. So, hope you got something out of this recording, and I'll see you some other time. Bye-bye.